Hello everyone, welcome back to Wider 360. Today I want us to look at how to solve this equation which says we should find the arc length of the curve x, which is a function of t and is equal to 7t plus 3, and y, which is also a function of t, which is equal to 24t minus 2. To solve this equation, we know that the arc length of a parametric curve is given by the equation L, which is equal to the integral of the square root of the first derivative of x all squared plus the first derivative of y also squared, from the limits given from 7 to 8. So we'll be using the upper limit of 8 and a lower limit of 7. What we will do is, looking at the equation, the formula, it wants us to first differentiate the function x and the function y, and after that we square both of them, we take the square root, and then we integrate over the limit. Without wasting much time, let's go ahead and differentiate x. So that will be the x dt. We are differentiating x with respect to t, and that's the same as the first derivative of x, as you can see in the formula. We go ahead, we say that one will be equal to we integrate this 7t plus 3 prime, okay, and that will be equal to 7. We will also go ahead and do the same thing for the y function. So doing that for the y function, we know that y is equal to, okay, let me write the whole expression for the y. Is equal to 24t minus 2. Y prime of t, which is the first derivative, that will be the same as dy dt, and that will be equal to 24. We go back to the formula, which was given as L, which is the arc length, is equal to the integral from 7 to 8 of the square root of x prime t all squared plus y prime t all squared. At this stage, we know the values for x squared t, x prime t all squared, and y prime t all squared. So we will go ahead and plug those values in. We will get the length to be equal to the integral from 7 to 8 of the square root of the x dt was obtained to be 7. So that will be x prime t, and then we will square that plus y prime of t all squared, which was taken to be 24. And we will square that one also. We will go ahead, get here to be square root of, that will be 49, I think, plus 24 raised to the power 2. So plus 24 raised to the power 2, which is 576. Continue, we get that to be 7. Let me realign here to 8. We sum those two up, which is 49 plus 576. And that will be equal to 625. And without wasting much time, keep in mind that since this is a function of t, if we integrate, we are integrating with respect to t. So this will have a dt here, a dt here, dt here, and a dt here. We have a square root sign over there. We will go ahead and work with the square root sign, which is the radical. So evaluating the radical gives us 25 dt. We are not done yet. We will go ahead and integrate this expression, which was given to be 25 dt. Which is definite integral. So to do that, we know from the fundamental theorem of integration or calculus, the fundamental theorem of calculus, that whenever we are to integrate a function, which is from a over the limit a to b of f of x, and we are doing that with respect to x, we know that is equal to f of b minus f of a. From this theorem, we can go ahead and say that the arc length will be equal to, evaluating this, integrating that. First of all, let's integrate the function. Let's integrate the function. Integrating will give us something like 25t over the limit 7 and 8. So we will go ahead and plug in the values of 8 and 7. So f of b here will be 25 times 8, and that of f of a will be 25 times 7. We evaluate this. 25 times 8 will be 200, minus 25 times 7, which is 175. We simplify this. 200 minus 175 will be 25. Therefore, the length of the arc, or the arc length, is 25 units.